Dear students, in the previous class I explained you Euclid's division lemma, and using Euclid's division algorithm we found HCF of two numbers. Exercise 1.1 main question number 1 and 3 we did. I was telling you main question number 2, 4 and 5 will be doing in the next class. Hope you must have done example 1 and 4, and I told you to go through example 2 and example 3. I don't know whether you understood it or not. So once I explained this exercise 1.1 main question number 2, 3 and 5, then if you refer example 2 and 3 you will understand it very clearly. Let's do example 1.1 main question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So its solution is, let A be any positive integer and B, let us take it as 6, because here it's given in the form 6q plus 1, 6q plus 3, 6q plus 5. So let us take B as 6. According to Euclid's algorithm, we know we used to write A as BQ plus R, where 0 less than or equal to R less than B. This is Euclid's algorithm. So here we are taking B as 6. So A will be 6Q plus R, where R can be from 0 to B say less. That means it can be 0, 1, 2, 3, 4, 5. Hope you understood it. If we are considering B as 6, how R will be? It is less than B from 0. So it can be less than 6 matlab 5. So 0, 1, 2, 3, 4, 5. They are integers. Now let's consider all this condition. If R equal to 0, agar R 0 hai to, then A will be 6q plus 0, which is 6q. 6q is an even number because it is 2 into 3q. It's a multiple of 2, which is even. Now, if R is 1, A will be 6q plus 1. You know 6q is even, so even plus 1 will be, it is odd, which is an odd number. Now, if R equal to 2, A will be 6q plus 2. So one number odd, then even. The first number is even, then odd, then again it will come even. Otherwise also you can see 2 can be taken outside, it's a multiple, which is even. And if R equal to 3, A will be 6q plus 3. You know, even ho gaya, so next will be odd, which is odd. If R equal to 4, A is 6q plus 4, which is even. You know, till 5 we have to do. If R equal to 5, A equal to 6q plus 5, which is odd. Now you see where all odd came here. First, when R equal to 1, this is odd, this is odd, and this is odd. Read that question. Thus, any positive odd integer is of the form 6q plus 1 6q plus 3 and 6q plus 5. So we can write thus. So if we are taking b as 6, you may think why we took b as 6. Because it's given in that form. Other if it would have given in 2q form, we would have taken b as 2. You can see in example 2 and example 3. Thus, any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 or 6q plus 5. So this is the sum. Please go through the procedure. First we are taking a as any positive integer and b we are picking it as 6 because in the question it is given in the form of 6q plus 1, 6q plus 3, 6q. If it would have been 7q, if it would have been 8q, we would have taken 8. If it would have been 9q, we would have taken 9. Hope you understood it. So we are getting 6q plus 1, 6q plus 3 and 6q plus 5 as any positive odd integer. Let's do question number 4. Again and again read it. Soon after this question, you can try exercise 2 and exercise 4. Not exercise, I'm sorry, example. Example questions, please try after this question. Once you understood this, once you go through this very nicely, please do example 2 and 3. Please learn this. It is exactly same. Now let's come to exercise 1.1, main question number 4. Use Euclid's division lemma to show that the square of any positive integer is of the form 3m or 3m plus 1. So as usual, let's take let a be any positive integer and in this case we'll take b as 3, b equal to 3. Therefore r is equal to, agar b 3 hai to r will be lesser than 3, which are the integers 0, 1 and 2. By Euclid's lemma, a is equal to bq plus r, where 0 less than or equal to r less than b. Now let's take b as 3 and r can be 0, 1 and 2. So let's take if r equal to 0. What will happen? A is equal to 3q plus 0. 3q plus 0 is 3q. Now here it's given square of any positive integer. We have to square it. Therefore a square is equal to 9q square. We have to prove that square of any integer will be of the form 3m or 3m plus 1. Can we write this as 3m? 3m. M can be anything. 3m. 9q square, I can write it as 3q square. So this is clearly of the form 3m, where this is m. m is equal to 3q square. Please understand this. So ho gaya a square, the square of a number in the form 3m. Thus we are getting a square is equal to 3m, where m is equal to 3q square. This is for r equal to 0. Now we will give next number r equal to 1. Let's see. When r equal to 1, what will happen? If r equal to 1, a equal to 3q plus 1, r is 1. Now I am squaring it. A square, because read the question. It's in question, it's given square of any positive number. So 3q plus 1 the whole square. You know a plus b the whole square, which is 9q square, a square plus 2ab 6q plus 1 is of the form either 3m or 3m plus 1. Can I take 3 outside from the first two terms, 3m? It will clearly come 3q square plus 2q plus 1. 3m I am taking common from first two terms. So I am getting 3m plus 1. So I am getting in the form 3m plus 1, which is equal to 3m plus 1, where what is m is equal to this in the bracket, 3q square plus 2q. So it has happened, this number a square is of the form 3m plus 1. So agar r 0 hoga, it's of form 3m. r 1 hoga, it's of the form 3m plus 1. Now let's try if r equal to 2, because we have three numbers to try. If r equal to 2, if r equal to 2, what will happen? If r equal to 2, a would become 3q plus 2. A will be 3q plus 2. So let's take its square. A square is equal to 3q plus 2 the whole square, which is 9q square plus 12q 2ab, 2 3s are 6, 6 2s are 12. 12q plus 2 square, which is 4. I can write this as 9q square plus 12q plus 4. I can write it as 3 plus 1. I can take common 3 from first three terms. I can take 3 common from first three terms. So what will I get? I can write it as 3 into 3q square plus from 12q 3 is out, to 4q plus 1 plus 1, which is clearly of the form 3m plus 1, where this is m, that is m is equal to 3q square plus 4q plus 1. So agar r 0 hoga, a is of the form 3m, a square I mean. R equal to 1, then a square is of the form 3m plus 1, and if r equal to 2 also, a square is of the form 3m plus 1. Thus, what we can conclude, it is there in the question, thus the square of any positive integer is either of the form 3m or 3m plus 1. First case we got 3m and second case we got 3m. Second and third case will. So when we take b as 3, r will be 0, 1, 2. 0 mein we are getting 3m and 1 and 2 mein we are getting 3m plus 1. It can be converted in the form of 3m plus 1. 4 is splitted into 3 plus 1. First 3 mein se common nikala. Once you go through this very clearly, again and again you go through it, and then example 2 and 3 also, you can understand. Now comes to exercise 1.1, main question number 5. It is cube. Pehle humne the number we consider, then we considered the square of the number. Now it is cube of the number. A we have to cube. That's all. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. So actually I told you, according to, if it is 4m we'll take b as 4, if it is 6m we'll take b as 6, if it is 3m we'll take it as 3. Now it is 9m, so we have to take b as 9 and r will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So all these cases we have to consider, but little bit if you are thinking, it is cube. Cube. So no need of taking 9. We can even take 3 क्योंकि 3 के क्यूब में 9 है. 3 cube is 27. 3 cube is 27 and 27 में there is 9. 9 into 3. So there is 9. So even if we take B as 3, you can take B as 9 also. Only the procedure will be big. You can do it. Very clearly you will get. These 3 forms you will get. But it will take long time. So instead of that, some schools or some teachers may teach taking B as 9 also. There's nothing wrong in that. But what I am telling is, since 3 cube contains 9, why can't we go B as 3 so that R can be given 0, 1 and 2. So I will be explaining in such a way. Don't get confused. Why we are taking in different way in different sums. Don't think like that. You can take 9. You can substitute all the values 0, 1, 2, 3, 4, 5, 6, 7, 8. Instead of that, to reduce the time and to do the sum logically, we can, you can cut short the procedure. We can take B as 3 also. Okay. 5th question. As usual, let A be any positive integer and B is equal to 3. By Euclid's lemma. These are all procedure to write. Euclid's lemma, A is equal to BQ plus R, where 0 less than or equal to R less than B. So we are taking B as 3. So A is equal to, therefore A is equal to 3Q plus R, where R can be 0, 1 and 2. Now we have to consider only these 3 cases. So first one is, if R equal to 0, what will happen? A is equal to 3Q plus 0 would become 3Q. Now I am cubing it. Cube. So A cube will come. 3 cube is 27. Q cube. I want to make it in the form of 9m. I can do it. I can write it as 9 into what? 3q cube, which is equal to 9m, where m is equal to 3q cube. So we got A cube as 9m when R equal to 0. Now the same procedure will do when R equal to 1. When R equal to 1. When if R equal to 1, what will happen? A is equal to 3q plus 1. Now I am cubing it. A cube is equal to 3q plus 1, the whole cube. You know, A plus B the whole cube. A cube, that is 27q cube, plus 3a square b, 3 into 9q square into 1, that is 27q square, 3ab square, that is 9q plus 1. I can take 9 from this. I will get 9 if I take outside. I will clearly get 9m plus 1 form. What will be m? It will be 3q cube plus 3q square plus q. This is clearly in the form of 9m plus 1, where m is equal to this thing, that is 3q cube plus 3q square plus q. So you got 9m plus 1. A cube is in the form of 9m plus 1. Now let's give R as 2. So what will happen? A is equal to 3q plus 2. So A cube will be, if if you cube it, 3 cube plus 2 the whole cube. So it will be, if you cube it, it will come 27 cube plus 3a square b. 3 9s are 27 into 2, 54 q square plus 3ab square. 4 3s are 12, 12 3s are 36 cube plus 2 cube, which is 8. I can easily take 9 from this. I'll get 9 into something, because all 9 will go. 3q cube plus 6q square plus 4q plus 8. This is very clearly in the form of 9m plus 8, where m is equal to this thing, isn't it? So, ho gaya 9m plus 8. So, first we got 9m, then we got, when r equal to 0, we got 9m, r equal to 1, we got 9m plus 1, r equal to 2, we got 9m plus 8. So, last sentence you can write, thus cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Please do these three sums, understand these three sums very clearly.